Yeah. Good morning, class. Till now, only 30 people have joined out of maybe 140. Hmm? Why so less strength? Anyway, okay, so we'll start today's lecture. Okay, so in the last class, we already started our earth pressure theories. Okay, so and I have given a brief introduction about the earth pressure theory. Okay, so just to motivate you, why we should study this chapter. Okay. So let me start with today's lecture. So all of you can see my PPT, right? All of you can see my PPT?
Yes, sir.
Okay. So in the last class, we briefly we saw what is the motivation to study this chapter. Okay. So as you know, in many circumstances in the field, you have to retain the soil almost 90 degree. Okay, which is not possible on its own. Okay, so to retain the soil almost 90 degree is not possible without any support. Okay, so to give that support, we will build these retaining walls. Okay, where if you build these kinds of retaining wall structures, then you can able to retain the soil almost 90 degree. You see, almost 90 degree, I can able to retain the soil with the help of this retaining wall. Okay, so to design these retaining walls, we need to know how much this soil is exerting a pressure on this retaining wall. Okay, so that first and foremost thing is due to this backfill. Due to this backfill, what is the pressure applied on this wall? Okay, so why I am writing this gradually increasing arrow marks here? And there is a reason, because as you go from the top, as you go from as you go deeper and deeper inside the soil, the pressure will gradually increase. Okay, so the lateral earth pressure will gradually increase like this. So this is called earth pressures. Earth pressure. Okay, once you know this earth pressure, then only I can able to draw then only I can able to design this retaining wall. Okay, so what should be the cross section of this retaining wall, and what should be the reinforcement details, all the things I can design once I know the earth pressure acting on that retaining walls. Okay, so that is the main objective of this topic. Okay, to study this earth pressure. Wait a minute. Okay. So, and also I have shown some failure examples of earth retaining structures in my previous class. Okay, so this is the example from Malaysia, and this is the example from Singapore. So these are all, see, you have to see this 30 meter, see here, almost a 30 meter excavation has been done. Okay, so can you see here, almost 90 degree they are retaining. Okay, so if you not, see, these are the retaining structures. Can you see here with red, whatever I am drawing here? So these are all retaining structures. So to see almost 90 degree, I am retaining the soil on this part and as well as soil on this part, right? So if you not properly design these retaining walls, then these kinds of failure will happen. So huge cost, huge even loss of life is there, of course, and also loss of lot of money involved in these projects. Okay, so that's why the importance of these retaining structures are very huge. So especially in metros, almost in metro cities. Okay, so all the metro cities almost the structures will be placed very close by each other, right? If you are finding any empty site somewhere here means almost surrounding this site, all the structures would have already built. All the structures already they have constructed. So once you do the excavation to construct any structure in your site, then it is your responsibility to safeguard these structures. Okay, so whatever the adjusting structures are there now, those things you have to safeguard. Okay, then only you can able to build the structure. Okay, so if you by doing some excavation here, if you even if a small cracks appears in these structures, then your project will be halted. Okay, because the owner of this structure will go to the court and they will sue you. Okay, so almost your project will be stopped. So that's why it becomes your responsibility to safeguard all these surrounding structures. Okay, so how you will safeguard all these surrounding structures? Because there's hardly there is any space between your structure and your upcoming structure and existing structure, right? So almost 90 degree only you have to almost you have to retain the structure very adjacent to these structures. Okay, so almost you will get a 90 degree slope here. Okay, so 90 degree slope, it is not possible to make in soil, right? So that's why you have to build these retaining structures. So to design those retaining structures, you need earth pressures. So this is syllabus also we have seen, and some video links I have shown you. Some failure of diaphragm wall, all those retaining walls, how they have failed. Some video, they have captured this in some videos. So those things I have put in your free time, you can watch them. So coming to the introduction, we started with an example from the swimming pool. Okay, so if you how you will retain the water in the swimming pool. To retain the water in the swimming pool, what you have to do? You have to build a wall like this, right? Then only you can able to retain the soil inside your swimming pool, right? Similarly, the same analogy can be drawn to the soils also. Okay, if you want to retain the soil almost 90 degree, then you should know you have to build these retaining walls. So there are different types of retaining walls we have seen. There are many types of retaining walls. Okay, so depending on the your field, depending on your field geometry or your requirements, you can build different kinds of retaining walls. Okay, so example is a cantilever retaining wall, braced excavation, anchored sheet pile walls, and then gravity retaining wall, soil nailing, and reinforced earth wall. Okay, all these are different types of retaining walls. Okay, so and also what is the importance of retaining wall? I told. Okay, so the importance of the retaining wall is to create a space where space is at premium. Okay. Okay, so and some field photographs of different types of retaining walls I have shown here. These are the sheet pile walls, again sheet pile walls, again these are the again sheet pile walls construction, and secant board piles. This is also a type of retaining walls. Okay, all these things I have explained in my previous class. Okay, so soil nailing also a type of retaining wall, Gabion wall, and a diaphragm wall. Okay, so nowadays in the metro projects, these kinds of walls are very common. So very commonly you will come across these kinds of walls. Those are called as diaphragm walls, especially in the metro projects. And this is another type of retaining wall called as a crib wall. So the specialty of these crib walls is you can grow vegetations here. Okay, so you can get some green canopy here. Okay, so it will aesthetically it will be pleasing. So another view of a crib wall, and this is the reinforced earth wall, and here one failure example of a reinforced earth wall from Turkey. Okay, so it's happened in very recent March 26, 2021. You see a big failure happened here. You can see here. So once we know the importance of retaining structures and different types of retaining structures, then our next aim is to understand how these retaining structures will deform. Okay, because the deformation of these retaining structures are important, right? So how they will deform? Okay, so if you have a gravity retaining wall, they will deform like this. Okay, so this is your gravity retaining wall, and here this is your deformation. Okay, so this is your backfill. Okay, so backfill soil. So the wall is moving away from the backfill. And this is the bracer excavation. Okay, so here also the wall is moving away from the backfill, and this is the abutment structures, bridge abutments. Okay, so in the bridge abutment, you see the wall is moving away, but you see the soil is present here. Okay, because see, this is your ground level, right? This is your ground level. Okay, so here whatever soil is there, now this soil has been compressed by this retaining walls. Okay, that means the wall is moving towards the soil. Okay, here the wall is moving away from the soil. And another type of retaining structure is anchored sheet pile wall. Okay, so the deformation shape is something like this. Okay, so because here there will be some this pulling kind of force will be there because of this anchoring. So that's why here also the wall is moving towards the soil. Here soil will be there, right? So these are the different types of retaining structures and their mode of deformation. Okay, so now we'll see a classification of lateral earth pressure. Okay, so there are three types of earth pressures. Okay, so if you see here, depending on the movement of these walls, we can classify earth pressures into three types. Okay, so what are those? Lateral earth pressures applied on the retaining wall. It depends on two things. One is type or nature of a backfill soil. What kind of soil is there, whether it's a clayey soil or whether it's a sandy soil. Backfill is the soil retained by retaining wall. Okay, so backfill means it is the soil which is retained by a retaining wall. So, and also that this lateral earth pressure, one thing, this lateral earth pressure depends on the type of soil, right? Let me take this cursor highlighter here. I think, okay. Yeah, then it will be easy for you to follow my notations, right? Yeah. Okay, so these lateral earth pressures, it depends on two things. One is soil itself, whatever, which type of soil you are retaining, and also the movement of retaining wall relative to the backfill soil. Okay, so depending on these two parameters, your lateral earth pressure depends. Okay, so according to the movement of the retaining wall, earth pressure on retaining wall can be classified into three types. What are the three types of earth pressures? One is earth pressure at rest. At rest means your retaining structure is not at all moving. This retaining structure is so rigid. So you are designing this retaining structure so rigid so that whatever soil pressure it is applying from the backfill, that whatever pressure is coming, that pressure is not able to move this wall. That means you are designing this wall very rigidly. Okay, so that means you will get a huge cross section. You will get so that whatever pressure it is acting on this wall is not able to move this wall. Okay, so this is the wall. So that means your retaining wall is stationary with respect to the backfill. Those that type of pressure is called as earth pressure at a rest condition. Okay, so next type is active earth pressure. What do you mean by active earth pressure? If this retaining wall is there, you design it flexibly so that the wall will move. The wall will move under the soil pressure, whatever pressure is acting on this. So what is the use of this designing? Is it as a flexibly, because you will get a smaller cross section. Once you get a smaller cross section, obviously the money or cost of the construction of these kinds of wall will be lesser. Okay, so you can save a lot of money, right? Because just by allowing to move this wall a few inches, you are not going to lose anything, because I don't have any superstructure over this, because okay, so by allowing a few inches inch of movement by this soil, you can save a lot of money involved in the construction of these kinds of retaining walls. Okay, so those are so in that circumstances, that kind of a movement is called as, or that kind of a earth pressure is called as active earth pressure. This is active earth pressure. So active earth pressure means the wall is moving away from the backfill. So the third type is passive earth pressure. That means the wall is moving towards the soil. Okay, so that means, see here, nobody is coming and pushing the wall or pulling the wall here. Okay, because you are designing the wall in such a way that the wall will move little bit. Okay, so maybe a few inches. So you so why I should do like that? Because I can save a lot of money here, because once I do the, see, if I design my retaining wall for active earth pressure, or if I design my same wall for the this earth pressure at rest condition, then there is a huge difference in the cross section of this wall. Okay, so here if the cross section of your wall, maybe if you are getting around some 50 mm thickness, here I may get just 10 mm thickness. You see how much difference. Just for example, I am telling you. So a lot of concrete you can save, and a lot of steel you can save, a lot of construction materials you can save, right? The passive earth pressure means the wall is moving towards the soil. Okay, so here with some animation I am explaining here what is earth pressure at rest, active earth pressure, and passive earth pressure. Okay, so this is the retained soil. I can call it as a backfill. So this is the backfill. This is the wall. Okay, so this is the retaining wall. This is retaining wall. Okay, so earth pressure at rest means earth pressure at rest means it is not at all moving anywhere. Okay, so that means it is a stationary. So that stationary means you are designing this wall so rigidly that whatever backfill pressure is there, that is not able to push this wall. Okay, so those are called as earth pressure at rest condition. Okay, so here the best example for earth pressure at rest is, see, if you are building your basements. Okay, so suppose I will explain this at rest condition in my coming slides, because there I have some beautiful structure. This figure, with that I can able to explain it nicely. Okay, so for time being, earth pressure at rest means the wall is not moving anywhere. Okay, so it's a stationary. Okay, now active earth pressure means the wall will start moving away from the backfill. So the wall is moving away from the backfill. Can you see here? This wall has moved now like this. And whatever soil is present here, that is exerting a pressure here. So that is called as wall moves away from the soil. Okay, so wall is moving away from the soil. And here, once, see, here also soil is there, right? Here also soil is there. While moving away from the soil on this side of the soil will be pushed inside. Okay, so that means the wall is moving towards the soil here. So here the wall is moving away from the soil. Here the wall is moving towards the soil. So the point A, whatever soil present at this level, is subjected to active earth pressure, and point B is subjected to passive earth pressure. Okay, because the wall is moving away from the soil backfill, that is called active earth pressure, and whatever soil present on this side of the retaining wall, that will be pushed inside the pushed towards the soil. Okay, so this wall is pushed towards the soil. That's why this soil, whatever soil present at element B, is subjected to passive earth pressure. Okay, so whatever element soil present at A will be subjected to what? Active earth pressure. Understood? No, the difference between earth pressure at rest, active earth pressure, and passive earth pressure. So let's look at the soil elements at A and B during the wall movement. Okay, so we'll see, we will dwell more detail about what will happen to the soil A and what will happen to the soil B. Okay, so here, see, this is the wall moment. On the x-axis, we have a wall moment. On the y-axis, this is the earth pressure coefficient. Okay, so on the y-axis, it's the earth pressure coefficient. Suppose this is the K0 condition. K0 condition means what? K0 condition means the soil is, sorry, the wall is not moving anywhere. Okay, so it's a fully rigid soil, fully rigid wall that is not moving. It is stationary. Okay, so the point is somewhere here. Okay, now what I will do, carefully observe the animation here. Okay, so now I have removed the soil here. Before the wall, whatever, this is my retaining wall with black line, whatever I ran now, this is the retaining wall. Now what happened, I have removed the soil. Okay, once I remove the soil, what will happen, the wall will start moving. Okay, once the wall is moving away from the backfill, what will happen, your pressure, whatever soil pressure is, that will be little bit relieved, right? So that's why you see the pressure is decreasing here. So this is what your active condition. That is, active condition means the coefficient, earth pressure coefficient, I'll represent it as a Ka. Okay, so Ka is active earth pressure coefficient. Okay, so K0 is what? K0 is your what do you call this? Stationary. Okay, so the wall is not moving anywhere. Okay, so now we'll see opposite of this. Okay, so that means the wall is moving towards the soil. Okay, so you see the wall is moving towards the soil. What will happen? The pressure is building here. Okay, so whatever soil pressure is, that will build. So that's why you see the. So the Kp is nothing but earth pressure coefficient, passive earth pressure coefficient. Passive earth pressure coefficient. So now you understood the difference between the active and passive. See, the passive passive earth pressure, the pressure will be very high here. If you design the so if you are designing any wall for this passive earth pressure, means you will get a huge cross section. But if you designing for active earth pressure, then your wall thickness will drastically, it will reduce. And K0 condition means stationary condition. So that means you should not allow any movement of the wall. You should not allow any movement of the wall. Okay, so in the field, okay, so in the actual practice, you will come across all these three types of wall movements. Okay, so you will come across in certain circumstances, you should not allow any movement of this wall. Okay, and in certain circumstances, you can allow certain movement of the wall. By allowing that, what benefit I will get? I will get a benefit that my cross section area of these walls will reduce drastically. I can save a lot of money here. Okay, so those kinds of circumstances also you will encounter in the field. Okay, and in certain circumstances, you have to design the wall for the passive earth pressure. So all these three kinds of scenario we will come across in the field. Okay. So this is your see, to produce the passive earth pressure, what is happening here? The wall should move to a greater extent. You see, this much wall it should move. How much? If you take a y/h ratio, that means the movement with respect to the height of the wall, almost 0.040. That much length it should move. Okay, so to obtain this passive earth pressure, that means the wall should move to a greater length. Whereas in active earth pressure, the wall movement is very small. You can see here small, even a few inch of wall, if it allowed to move, then you can able to get these active earth pressures. To get this passive earth pressure, you have to move, the wall should move to a greater length, maybe a few centimeters. Again, same graph I am, the same graph I have put in some other perspective here. The same thing, okay? So at rest condition, the wall is not moving anywhere. Active earth pressure, the wall is moving away from the backfill. And passive earth pressure, the wall is moving towards the backfill. And how much length of wall should move to obtain these different earth pressure? I have given table here. Okay, so no need to remember, just to feel about these numbers. That's the purpose here. Okay, so no, don't try to remember these things. Okay. So for dense sand, you see what should be the, it is a ratio for the active state, and this is the passive state. So horizontal displacement with respect to wall height. So that is the ratio. That means the wall movement with respect to the height they given. So if that ratio is 0.001 in dense sand. So if it is a soft clay, then see, relatively it should move to the larger distance. Okay, so just you compare these two numbers, how much difference? Almost double, right? 0.02, 0.04, almost double. That means the wall should move to a greater length in the passive state as compared to the active state. Okay, so now we will study about the earth pressure at a rest condition. So where you will encounter this kind of a scenario, where you will encounter this earth pressure at a rest condition. Okay, so suppose if you are building a multi-story structure with some basement walls, you see this is the basement wall, and this is what? Soil, right? This soil has to be retained, right? Almost 90 degree it is retained. And what will happen? This whatever this wall is there, no? This wall is subjected to some earth pressures from the soil. Okay, so whatever the surrounding soil is there, no? This surrounding soil will apply a earth pressure on this wall. This is the basement wall. Okay, so you have to design this basement wall for the earth pressure at rest condition. You have to design this wall for earth pressure at rest condition. Why I should design? Because see, in my previous slide I explained you. So if you design any wall to the for the earth pressure at rest condition, then the cross section of these walls will become huge as compared to active earth pressure. Okay, so why I can't design this wall for the active earth pressure? So that I can save money. Can you tell me, anybody? See, the same wall, if I design it for active case, the same wall, if I design it for the active case, I can save a lot of money, because my cross section of these retaining walls will reduce drastically. But I can't design for the active earth pressure coefficient or active earth pressure condition. Why I can't design? Because if you design for the active case, then what will happen? The wall will move away from the backfill. Okay, so this whatever soil is there, no, away from the backfill, this basement will move. Okay, once this basement is moving away a little bit, okay, even few inches, if it moves, then what will happen to your superstructure? What will happen to your superstructure? Okay, because all your superstructure is supported on this wall, right? All these superstructure, your first floor, second floor, all these floors are supported on this wall. Okay, once this wall is moving away from the backfill, obviously this wall also will try to move, or once if it is not allowed to move, then what will happen? The cracks will appear. The cracks will appear. Okay, so then the safety issues will come, right? So that's why these basement walls, I should design it for the at rest condition. I should design these basement walls for the at rest condition. if I design it for the at-rest condition, even I can my cross section may increase, but I can't compromise on the superstructure. Okay, so that's why I have to design this retaining wall for the active case. Earth pressure at not active case. I should design it for the earth pressure at rest condition. So this is another sectional elevation of your structure. Okay, so which is having some basement. So always these basement walls, whatever these retaining walls are there, no, these are nothing but retaining walls. These are not a common your brick wall. These are a retaining wall. Understood now the difference between active and passive conditions. I think your next class is scheduled. Okay, I will stop it here. Any doubt regarding this? Any doubt? Prasad, Neha, Priyalakshmi, Savita, any doubts?
No, sir.
Okay. So I will stop it. I will stop the recording here. Then we will meet tomorrow.